Today, in this video lecture, we will see this fourth numerical on Rankine's formula. So, first see this numerical. A short length of tube of 40 mm internal diameter and 50 mm external diameter failed in compression at a load of 240 kN. So, see, this is tube of internal dia small d and external dia capital D. Small d is 40 mm and capital D is 50 mm. That means this thickness is 50 minus 40, 10 mm. So from that first statement, a short length of 240 mm internal dia and 50 mm external dia failed in compression at a load of 240 kN. So right here, failed in compression, and this load is 240 kN. PC written as because this is compression load, because that column is failed in compression due to that load, so that's why PC 240 kN. Okay, now move toward next. When 2 meter length of the same tube was tested as a stud, same tube, that means that cross section is same, that is circular tube, internal dia 40 mm and external dia 50 mm. So when 2 meter length of the same tube was tested as a stud with fixed end, the load at failure was 158 kN. Now this second is one end fixed and other is also fixed. See here, when 2 meter length of the same tube was tested as a strut with fixed ends, the load at failure was 158 kN. Okay, wait for a second. Assuming that sigma c in Rankine's formula is given by first end. Okay, this is correct. Actual length is 2 meter. Actual length denoted as capital L. And see, for that shape, how is that buckling behavior like that. So from that shape, we are able to talk about that L effective length. So what is effective length here? When two ends fixed, that means effective length is equal to actual length divided by 2. Yes. And with 2 meter length of the same tube was tested as a stud with fixed ends, the load at failure was 158 kN. This is load at failure, that means this is crippling load, 58 kN. Okay, assuming that sigma c in Rankine's formula is given by first state, so you know that we always use that sigma c in Rankine's formula, and this is first state. So, and sigma c stress is nothing but the load upon area. Here, this is PC, this is sigma c, because here this is PC. So this PC is 240 kN and area. Now calculate area. Area is equal to, this is hollow circular shape, so that's why pi by 4 capital D square minus small d square. pi by 4, capital D is 50 square minus small d is 40 square. So therefore pi by 4 into 50 square minus 40 square, it is 706.858. And unit is mm square. Now this sigma c is see this 706.8 is in mm and this is in kilonewton. So convert this is into Newton. That means Newton, that means multiply it by 10 raised to 3, 240 into 10 raised to 3 Newton. So 240 into 10 raised to 3 divided by 706.858. It is 339.53 Newton per mm square, unit of stress. So yes, this is also correct. Now find the value of the constant alpha. Okay, what will be the crippling load of this tube? So find the value alpha. What will be the crippling load of this tube? See, this is not stress. This is load. PCR. See this 158. Load at which failed. Load at failure was 158 kilonewtons. So this is load P. And find the value of the constant alpha in the same formula. What will be the crippling load of this tube? So that means they are telling us that find alpha for that same state. See here. Find alpha and what will be the wait, wait. So here in this we will find alpha. Okay, yes, find the value of the constant alpha in the same formula, and this is different. What will be the crippling load of this tube if it is used as a strut of 3 meters? So here on this third, if this is 3 meter actual length, then what will be the crippling load of the stitch if it is used as strut 3 meter with one end fixed and other end hinged? See here, boundary condition is different. One end fixed and other end hinged. And statement finding problem is crippling load PCR. Here you know that this is deflect like this. That means LE is equal to L by root 2. Okay, and this, how to find this PCR, I will tell you this. First calculate this alpha. See, PCR is equal to sigma C area upon 1 plus alpha and LE by K square. we have that PCR 158 kilonewton. That means in Newton it is 158 into 10 raised to 3 Newton. And this sigma c is that, see, they told us that assuming that sigma c in Rankine's formula is given by first step. So this is Rankine formula, this is sigma c in Rankine's formula, and this is first step, and sigma c in this first step is 339.53. Now area see 706.858. Area is also same because that section is not changed up to second that case. 808.858. Sorry, area is 706.858. Yes, 706.858 divided by 1 plus alpha and LE by K. See, LE, what is LE? LE is equal to L by 2. That means LE is equal to 2 by 2. That means 1 meter. That means in mm it is 1000 mm. LE is 1000. K. Now K. How to find K? K is equal to under root of I by A. So for that K, see, K is equal to under root of I by A. Okay, radius of gyration. So this I is nothing but the pi d raised to 4 by 64 for that hollow circular shape. Pi small d raised to 4 by 64. So this pi by 64 take common. Capital D is 50 mm, 50 raised to 4, minus small d is 40 mm, 40 raised to 4. So this I is equal to pi by 64 into 50 raised to 4 minus 40 raised to 4. It is 181,132.45. And that unit is mm raised to 4. So this I is equal to 181.132 into 10 raised to 3 mm raised to 4. Calculate this again. Pi by 64 into 50 raised to 4 minus 40 raised to 4. It is 181,132.45. Yes, it is correct. Now put this here. Now by using engineering calculate this alpha. So first draw bracket, this is in bracket, this is in bracket. So bracket, again bracket, again bracket, 339.53 into 706.858 divided by 1 plus alpha into 1000 divided by 188.132 into 10 raised to 3 square of that and shift solve. See, I think we had make mistakes here. This is only I, and why we put I here directly in K. This is not K, this is I. K is under root of I by A. K is equal to under root of 181.132 into 10 raised to 3 divided by A, area here, 706.858. So this K, now calculate K, 181.132 into 10 raised to 3 divided by 706.858 and under root of that. So it is 16 mm. K is 16 mm. So last time we directly put this I in that K. So this was wrong. So now use that K 16. Okay. Now solve it again in engineering calci. Shift solve. So this is 1.3328 into 10 raised to minus 4. And alpha don't have any unit. Yes, it is correct value of alpha. Now move toward our second objective. Now see here our objective is PCR. So and see numerical they taken that name Rankine's formula. That's why we are solving with the help of that Rankine's formula. PCR is equal to sigma CA upon 1 plus alpha Yeri by K square. So here only what is changing, that effective length is changed. So effective length is equal to 3000, because this is 3 meter, that means 3000 mm divided by root 2. So 2121.32 mm is effective length. PCR. Okay, use that sigma C same, that is this 339.53. Area 706.858 divided by 1 plus alpha. See this alpha, we had calculated it, 1.328 into 10 raised to minus 4 into LE. Now LE is different, LE is 2121.32 and K is also similar because that, see, material and that shape is similar. K 16 mm and square of that. Now calculate this. PCR is equal to 339.53 into 706.858 divided by 1 plus 1.328 into 10 raised to minus 4 into 2121.32 divided by 16 and square of that. It is PCR is equal to 71977.37 kilonewton. Why this is coming in kilonewton? Because see, this is in MPa, this is in mm, so that's why 71. This sigma Ca, is it in MPa? Yes, this is in MPa. 71977.37 and unit is Newton. So that means 71.97 kilonewton PCR. So that way we had solved this numerical. First understand this numerical and then break this numerical in that 3 to 4 steps and solve it like that. Stress is load upon area, that boundary conditions, that both end fixed, effective length is actual length by 2, that Rankine's formula. Here there is multiplication between both of them, that sigma C and A. So that way our numerical completes. Thank you very much.